Good morning, everybody, and welcome to today's Celsius City Talk. My name is Sarah Johnstone, and I will be moderating today's webinar. Today, we are focusing on our member city, Dublin. Dublin is working on the establishment of their first district heating network in a country with little experience of district heating and cooling. A key challenge they are facing here is integrating a hospital into the new network, and they've asked Celsius to share some ideas and experience to keep in mind in their work in this area. So we will first be hearing from Donna Gartland, who will present Dublin's case in more detail, and then we will give the floor over to our amazing array of experts. Peter North will discuss the role of the public sector in district heating, and Michael King will focus on the important issue of anchor loads as a way of managing risk. We will then hear some practical experience from Ola Nordgren about connecting a hospital in the Swedish city of Gävle to the district heating network. And we'll finally hear from Per-Anders Tausen on CHP and security of supply. Time allowing, we will finish with a Q&A from the audience. So let's move straight on to the first presentation. Donna Gartland is a strategic sustainable energy planner at CODEMA, which is Dublin's energy agency. And she is responsible for strategic, action-oriented, local-level energy planning and development of energy policy. She has been working to progress plans for district heating in Dublin and developed the first heat demand density maps and the first guide to district heating in Ireland. She's a qualified electrician with a degree in energy and environmental engineering and a master's in sustainable energy planning and management from Aalborg University. And she's currently carrying out a PhD on the possible impacts of district heating implementation in Ireland. So Donna, the floor is yours.
Thank you. Good morning. So I'm going to present the South Dublin district heating project.
Great. I'll just remind you to take, yeah, perfect.
Yeah, so taken over there. So I'm just going to kind of give you firstly a background into district heating in Dublin for those of you not familiar with the situation here. So at the moment in Ireland, in general, there are not many district heating systems. We've only got one district heating system at the moment established in the south of Ireland. That's quite a small system which connects some public buildings and social housing to biomass boilers. But at the moment in Dublin, we don't have any what we would classify as district heating systems. There are some kind of small individual building-based shared heating systems, but no what we would call district heating systems. So nothing that would no kind of public sector district heating systems. At a national level, we have no regulations, policy or financial or fiscal supports available. So obviously them with no experience of actual district heating and no national level supports, there's very high level of perceived risk around developing district heating systems in Ireland. So the district heating system that we are planning in Dublin is from a very much a bottom-up approach, and we're South Dublin County Council have been very active in progressing the plans for district heating. So we're establishing now the first phase of a district heating network in South Dublin, and this is made possible through the HeatNet Northwest Europe project. So CODEMA are the lead partner on this project. It's an Interreg Northwest Europe project, and there's 6 pilot regions that will be looking to either develop or extend existing district heating networks using fourth generation district heating principles. So South Dublin County Council are the Irish pilot, and they are providing funding for the district heating network, which will be match funded through the EU HeatNet project. But obviously, in order to receive this funding, the network must be built out in the next 3 years. So we're starting to get the ball rolling now, and it's time for some action in this area. So we're looking now to the Celsius Cities project for some guidance from the expertise in this area. So just to give you a background of South Dublin itself, South Dublin is one of 4 municipalities in the Dublin area, just to the southwest of Dublin City. and we developed a heat demand density map for the region as a first step, to see exactly where district heating is most suited. So this is based on European best practice methodologies, specifically from the likes of the Heat Roadmap Europe project. So we've learned how to map heat demand density, and in this case we base it on terajoules per kilometre squared. So in the map there you can see any of the areas that are coloured kind of light yellow to red would be deemed suitable, would have the kind of heat demand densities that would deem district heating viable in those areas. So you can see there's a lot of areas there where we can start progressing district heating. But we took the centre, the town centre of the South Dublin region, which is called Tala, as the kind of first stage, because they have a lot of high heat demands in close proximity, and there's a good mix of buildings in the area. So to develop the first phase district heating network in South Dublin, we're looking at the area shown. The energy centre site in the centre is a site owned by South Dublin County Council, and where we're planning to build the energy centre itself. You can see to the north of this site is mainly industrial area. It's surrounded by a national hospital, local authority buildings, and close, not too far away, is a large residential area, a large retail centre, and a college campus. And also in the top right corner there, you can see there's a new data centre being built not too far away. So we've kind of zoomed in on this area as a high potential area for district heating, and in the first phase we're going to concentrate particularly on this area here. So we're going to look at connecting the National Hospital and the local authority buildings to the energy centre site as the first phase, and then look to connect to some of the other surrounding large energy demands at a second phase. So in order to kind of design this system and see what is most suitable from a fourth generation district heating perspective, we firstly modelled the hourly heat demand. So you can see here that this is a typical month of heat demand in winter, where the peak heat demand is around 6.4 megawatts and the winter baseload of around 2.5 megawatts, which drops in the summer in July, August of a baseload of about 1 megawatt. And also we've modelled the electricity demand of the hospital, as we have potential to supply the hospital with electricity as well as heat. So the peak demand there is about 2 megawatts of electricity consistently throughout the year, with a base load of 1 megawatt. So from this information, we are now looking at different technology options that will supply these both the electricity and heat demands of these buildings. So we're looking at air source heat pumps. So in Ireland we can achieve a COP of around 3.2, but unfortunately these air source heat pumps alone can't reach the temperatures of around 80 degrees Celsius that we require in order to feed the heat demands of the hospital. Water and ground source heat pumps, we've investigated the geothermal sources in the area. So the aquifers with high yields are not likely, but a vertical closed loop system could still be an option. And as was shown in the last slide there's a data centre being built very close, within 700 metres of the energy centre site, so there's possible waste heat recovery from the data centre as well. Obviously, biomass or gas CHP is also an option in order to feed the electricity and the heat demands. So the site itself is quite easy for access for biomass deliveries, but there may be problems with particulates in the area because it's very close to, it's in a high density area, very close to the hospital and residential areas. We may not be able to supply electricity directly to the hospital because in Ireland we have a private wire network regulation, which means you cannot supply electricity directly to another privately owned building on another site. So the electricity must go through the distribution system. So at the moment we're trying to find a way around this, but it may not be possible to supply electricity directly, and in this case we would have to supply to the grid if we're looking at CHP, and grid connections can be expensive and take a long time. Biomass boilers, again, it's easy access for biomass delivery, but again, particulates may be an issue. So we're looking at either some of these technology options or a combination of the above in combination with thermal storage in order to maximise the efficiencies of any of these systems. So the main issues for the project are the energy centre itself. What is the best mix of technologies to use in order to meet these heat demands and to reduce the costs, and also to achieve some aspects of fourth generation district heating? The National Hospital, how can we ensure security of supply, which is obviously a big issue for the hospital. And also we have a problem in the hospital at the moment with the delta T, which is the difference in the flow and return temperature, which is very important for district heating in terms of losses and the operation of any of the technologies such as CHP or heat pumps. So at the moment we have a flow temperature of 78 degrees and a return temperature of around 74, so there's only around like a maximum 4 degree delta T at the moment, which is a problem that we need to find a solution to. And in South Dublin, for South Dublin County Council themselves, this will be obviously the kind of first district heating system established by South Dublin County Council. So what is the most suitable business model option for South Dublin County Council, and what would be attractive business models for ESCOs in this case, and what would be the best procurement approach in terms of, should we look at separate contracts for designing and building the network and the energy centre, or should these ideally be designed and built by the same company? So these kind of questions we would like some advice on from the Celsius experts. So yep, that's it. Thank you very much.
Thank you very much, Donna. I'll just go right ahead and give the floor over to our next presenter, Peter North. Peter holds a Peter holds a Bachelor of Science in Engineering and a Masters of Science in Building Services Engineering. He's a Fellow of the Institution of Mechanical Engineers and a Chartered Engineer, and he's currently working with the Greater London Authority as a Senior Manager for Programme Delivery in the area of sustainable energy. His main role is supporting both the development and delivery of larger-scale urban heat network projects, including the innovative application of local energy production to meet the Mayor's commitment for London to be a zero-carbon city by 2050. He has a long experience in the energy sector, particularly with projects combining engineering and commercial structuring and financing. So I'll give the floor straight away to Peter North. Take it away, Peter.
Okay, good morning. Can you hear me okay?
Yes, we can.
You can. Okay, that's great. So good morning, everybody. I suppose I'm really not that interested in district heating, just to shock you all. So the presentation really today is what the public sector role is in fulfilling the city's climate change objectives. And as we go through, it'll become evident that district heating in certain circumstances is quite fundamental as an enabling technology to allow the access to cheap, low carbon or zero carbon energy and supply that to London's buildings. So we think about it very strategically, and then we begin to drill down through strategies and policies, and then solutions to establish projects, and then figure out how these are delivered, and in total they begin to come together to deliver some of the mayoral objectives around climate change, ensuring London does its bit to ensure that global temperature rises are contained to less than 1.5 degrees C. So district heating for us is an enabling technology. You'd often hear it's technology agnostic, doesn't care where the heat comes from. But because it's widespread infrastructure within city areas, it's essential if we're going to take advantage of this, then the city actually takes a significant lead in ensuring its planning and implementation. The first few slides really, so what I'm going to do now is use some of the London case studies to illustrate how public sector in a city where district heating isn't traditional, unlike the Nordic countries, has gone about the planning, development and support of heat network projects. London, like many cities, is facing big population growth, massive pressure on resources, housing, transport, education, and it's also increasing demand on energy and energy infrastructure. We therefore need to become more self-sufficient in energy as cities, and also take advantage of smart technology developments to ensure we get the very best out of the infrastructure capacity we install. So we think very much about new energy vectors, energy sources, and so on and so forth, and how these will be delivered within cities. It's important we begin to think about using less resource and introduce in particular renewables and non-polluting sources. We can't avoid the fact that energy production locally produces air quality issues. London's in breach of its air quality limits already. So these are some of the many parameters that we got to deal with when we're thinking about energy in our cities. And it's also important that we think about our role as part of the national energy system to contribute towards security of energy supply. And also we begin to envisage storage of energy, both electrical and thermal, as being quite fundamental into an optimized system. So the biggest CO2 emitter in London, and in fact most European cities, is the energy consumed in building heating. So it's we consume more energy than we do in power generation or transport, but it's the least thought about source of emissions, and it has the least regulation and policy in place. So the Mayor has several instruments that came into place. The GLA Greater London Authority was established in year 2000. Has established a number of key documents such as the London Plan, and that really sets out the policies for London, that it will contribute towards CO2 reductions, and has a certain amount of planning power requiring new developments to either connect a new heat network, or to connect to heat networks if they exist. Of course, we have very little in London, or install own CHP. So that's been sort of moderately successful, but there are still much larger scale projects that can be done that the London Plan doesn't really establish. The Mayor has produced his climate change mitigation and energy strategy. Another key document sets targets for London. The key ones for me are that 25% of London's decentralized energy consumption is supplied from decentralized energy by 2025. We think this is about an £8 billion investment opportunity. So how do we actually get investments into London of that scale? What role does the Mayor have to play to remove the barriers for principally private sector to play its part? If we can get the private sector to play, then we'll come a long way in trying to meet these targets. And our new Mayor in 2016 pledged London to be a zero carbon city by 2050. So very, very challenging targets. We're in the process of developing more planning tools to inform our policy officers. We're rewriting both the London Plan and the London Environment Strategy. And the London Energy Plan is a tool that will be rolled out in the next couple of months, which will help us develop their various scenarios, technical scenarios to meet London's heat requirements. So fundamentally, we sort of classify decentralized energy into one of three types. Type 1 are small gas engines located in individual buildings. The London Plan delivers those. And the Type 2 and Type 3 are larger scale schemes centered around a single energy center with multiple consumers, heat consumers. And at this stage, we begin to see the introduction of heat networks as the energy carrier connecting the energy source to consumers. So most of our work is at the moment is around establishing the Type 2s with an ambition to become Type 3s where they take large amounts of surplus heat from power stations, energy from waste plants, and transmit these over transmission networks and distribute locally using local heat distribution networks. And this is very similar to what we see in the Nordic countries, and this is what we're planning to try and achieve in the coming years. So the London heat map, Donna has her heat map, so this is the London version. Identifies where the most heat dense areas are and therefore theoretically best lend themselves to district heating solutions. We take those and we've been providing, the Mayor has been providing technical, commercial and financial advisory support, starting with heat mapping, moving on to the energy master planning where we try and establish the extent of market competitive heat networks. Master plans acts as evidence base for local planning policy and helps develop appropriate policies in the boroughs to promote and require heat network projects, decentralized energy projects to be developed. But there's a further role then for boroughs to get involved in delivering projects, and that's taking them through the conventional chain of feasibility study, business case, business plan, procurement, and into commercial operation. Master planning, as I've already sort of discussed, is about establishing the roadmap for the specific area. And typically from this we would identify satellite clusters that would be built initially with a view to, over time, interconnecting to interconnecting to form the large area network. These will take 15 to 20 years to evolve, but without the master plan you are blind as to what the potential is and the direction and technical requirements of the satellite scheme. So for me these are fundamentally important to area-wide networks. Some of the big energy sources, sort of largely untapped, but this is now changing, are in London's energy from waste plants, typically steam turbine electrical output, efficiencies very low in the low 20s, 25% efficient. We now have worked with Salchip and Lee Valley Heat Network. In fact, we've engaged with all the energy from waste plants, some of which have now established heat networks on the back of them or in the process of doing that. And every new plant in London will be built as a combined heat and power plant, and we work very closely with them to ensure that the heat offtake is carried out at the pressures and temperatures that would lend itself to the lowest possible cost heat supply. It's a very important aspect of energy from waste plants. Further examples, some of the early work we've done in connection with the hospital, unlike Dublin where you're aiming to supply the hospital, this particular case is in Camden, where the hospital is supplying a local community network. The community network was previously heat-only boilers. A new gas turbine was popped into the hospital. It was a steam system, and therefore there was about 2 megawatts of heat available in the exhaust gas, which was exhausting at about 180 degrees C. So an additional heat exchanger was incorporated there to recover that heat. So the hospital didn't have too much to do with this. But the ESCO then installed and refurbished the hospital's energy system, a company called Mighty. That's who we dealt with, or Camden dealt with, to establish this heat recovery and the connection to the estate communal heating systems. One really important aspect of all this study work, and we are beginning to promote this more and more, is carrying out the risk register, establishing a risk register for the project. And I'm not sure if you can read that, but there's a whole range of issues that you need to consider, and that helps shape how you go about procuring the plant and equipment, and who you contract with, and and how much you can rely on. Bitter experience in London is you can't rely on any commercial buildings or commercial heat suppliers for their longevity in their heat supply. So Donna mentioned data centers. What happens in 5 years' time when technology changes, or they relocate, or suddenly technology improves to have no heat. So we've worked with commercial power plant, sugar refiners in London, all of which were unable to commit long term. So in developing and designing your schemes, you've got to really think hard about the either the energy source, its longevity, or your key anchor heat loads. And the concept here for heat networks is to connect as many heat consumers as possible to get very diverse energy base and ensure very high operational efficiency, high load factors, and not rely too much on single large institutions as heat customers. So quick summary. Public sector has a fundamental role in establishing heat networks in cities. It's to establishing the appropriate strategies and policies. Then it's going through the development, the evolution of the energy master plan that gives us the roadmap, the long-term roadmap to achieve the strategy objectives, policy objectives, CO2 emission reductions in London's case. Then trying to establish major heat producers. Energy from waste plants are very good in London because they're usually connected to 40-year municipal waste contracts with councils. So we go after those with great enthusiasm. And then furthermore, the public involvement will be about establishing the relevant planning policies around heat networks, requiring developments and developers to safeguard routes and space for energy centres, particularly where we're crossing rivers and rail lines and difficult barriers. Can provide their own buildings, which gives you some better assurance around heat load guarantee. Public sector can also finance projects at lower rates of return than private sector. Also develop delivery vehicles, particularly useful around schemes that have long-term build-out plans, because the public sector can take different investment decisions than the private sector would. Therefore, lends itself better to, in my view, into larger scale schemes. And not only that, these schemes can also deliver on local policies. In particular, we think about fuel poverty, carbon reduction, etc. The public sector doesn't have to stay in these projects forever. They can exit at certain points when it builds up, when the cash flows build up, and can be demonstrated. We can also refinance at later dates as well. So that was my presentation.
Thank you very much, Peter, for sharing the experiences from London. Donna, do you have any questions straight away for Peter?
Not straight away. Maybe
Okay.
I'll think of something I can ask towards the end.
Yeah, there will be another chance at the end where we can open up for a Q&A for all the presenters. So then we can move right along to our next speaker, who is Michael King. Now, Michael has worked in the district energy field for 22 years, and he was a founding director and initial chairman of the Aberdeen Heat Network, and he remains on the board there. He's advised on district energy projects for a wide range of local authorities and also with government-supported agencies on focusing on district energy advisory and capital programs, including the Energy Savings Trust, Carbon Trust, and Homes and Communities Agency on the Low Carbon Infrastructure Program. He is the author of several research and guidance materials, notably Community Energy, Planning, Development and Delivery, which is based in the UK, but has also been republished as a country-specific guide in the US and Canada. Currently, he's the chairman of Coheat, which is a startup developing fifth-generation district heating projects. So, Michael King, the floor is now yours. Please take over as presenter. Michael, are you with us?
Right, I beg your pardon, it's that I had my microphone on mute. Can you hear me now?
Yes, and can you take over as presenter as well, please?
You have.
Perfect. Okay, good. Yes, I see that now. Okay, all right, and we can hear you, so go ahead.
Okay. Good morning, everyone. Is that if I can start by apologising firstly because I have the tail end of a cold, so if I start spluttering in the middle of it, is that please excuse me. Secondly, by way of introduction, is that although I am a board director of Aberdeen Heat and Power, I am in fact a Londoner and I'm sitting here in London right now. But I have been involved with Aberdeen for some 20 years, and so I go up there very, very frequently. So I'd like to sort of start by, I feel that the best place to start is actually try to figure out for any kind of heat network, what are the objectives or key motivations for the stakeholders involved in any particular project. And I use this particular spider diagram approach in working with local authorities, housing associations and others that are doing this, where kind of ask each individual to score these things according to their priority, and the blue shape in the middle contorts according to what they are. So in this particular instance, you can see that their kind of priority was revenues, followed equally between energy security and affordable heat. The slight kind of irony was that in this particular case is that everybody there actually kind of worked for the Department of Economic Regeneration, which seemed to be the most popular motivation. So the key kind of technical requirements for doing heat networks are heat density, because the closer the buildings are together, the less pipe that you have to put in to connect the two together, and so that of course means reduced capital cost. The second item is diversity, because if you've got a diverse loads, and there's some indications on the right hand side of different load profiles for different types of consumers, residential, commercial and entertainment, and you can see that you can actually kind of serve more people or more loads from the same pipe if you have a certain amount of overlapping loads, so that kind of diversity is important. The third thing is the presence of anchor loads, which is really the focus of my presentation here today. These are, if you have a shopping mall development and you need to get in an anchor tenancy, such as Marks and Spencer's or John Lewis, in order to get the development to stack up, because once you've got them involved, is that all the card shops and shoe shops and minor retailers will follow on afterwards. The same thing here is that if you get kind of key anchor loads in, then you can actually connect up smaller ones on the back of that that kind of cornerstone, if you like. And these are typically public sector organizations, so hospitals, prisons, universities, but also social housing estates. They can also be private in terms of hotels, leisure centres, and what have you. But the point, overall point, is that district heating is not a panacea. It doesn't kind of work everywhere. But where these kind of three elements are present, then it should be considered. So one of the kind of organisations that I've worked for in the past has been, well, I'm still currently working for them, is London Borough of Islington. And they put all these pieces of information, this data together in the heat mapping exercise that they did on the left. And this was then kind of refined to the one on the right, which actually kind of helped them identify where these kind of clusters of projects should be. And you can see that, that these then are linked together to show a kind of broad sweep of how a heat network may develop through the borough. And the one that has actually been advanced at the moment is Bun Hill, which is the one right down there on the southern end, the south, the right-hand lower side. They're currently kind of engaged in, with Peter's support, I might add, with ones in Archway up in the top left-hand side, and the Nags Head Town Centre in the middle. So both of those are under development. Now, these are the kind of the key commercial requirements as I see them for heat networks. The first kind of access is control, and control it relates to the objectives that you have set for yourself. So that certain objectives need more control. So if you actually want to develop a heat network for regeneration purposes going throughout an area, then you most probably need control. Whereas if it's simply about carbon reductions, then you most probably don't, because the technology will deliver it, whatever. But if you're handing that over to, say, for example, a third sector organisation, there's a possibility that they will cherry pick the key anchor loads and not take it any further. So consequently, the degree of control that you have over it will enable you to develop, to deliver your objectives depending on what they are. The bit in the middle, which is the cost of capital. Now, the cost of capital relates to what the rate of return a project will deliver. If a project will deliver a rate of return of, say, 7%, and you can access public sector capital through, in the UK, this would be through the Public Works Loan Board at 3.5%, then the project is viable. If you can't do that and have to go to private sector capital at 10%, then the project is not viable. So it is a relative situation, and one has to take that into account. The third element down the bottom, which is one of the ones I'm focusing on today, is risk, because the management of risk will actually impact upon the cost of capital. Investors, whether they are public sector or private sector, will actually cost the risk involved, and that will be presented in the rate of return that they require on the capital that they provide for you. So risk is important. These three things, these three elements, need to be taken into account in actually deciding what the delivery vehicle is for a given project. And here is an example from the Scottish Futures Trust, where they have on the left-hand side a public sector controlled organisation, so they've got maximum control over it, but they actually have maximum bearing the risk as well. Over to the other side, whereas that control is reduced, but there is the transfer of risk onto that third party. Now, one way of actually minimizing risk is to take a strategic approach, and this is one that I produced back in 2009, 2010, and seems to be the granddaddy of them all. But the general kind of idea is that you kind of progress through these various stages where the clarity and detail of the project becomes clearer, and consequently the risks involved are reduced. But each stage costs money, so you will need to actually invest in order to kind of undertake this process and reduce risks. So in terms of managing risk, and Peter mentioned the Upper Lee Valley Heat Network, and I am on the board there, and we've just actually had green lighted earlier this week the refurbishment of the Edmonton Energy from Waste plant, when we'll be taking the heat from that. But this particular slide is a management tool developed by the Upper Lee Valley Heat Network, and managing risk is a general management tool in most kind of project development, and so it's not exclusive to heat networks, but it follows the same process of identifying, analysing, mitigating, and reviewing in this process. And key to this is actually having a risk register, and here is one that was done for Islington, and in it one actually identifies the risks, one finds out who owns it, describe them, assess their impact, their likelihood, and then come up with a mitigation strategy of how those can be reduced, and then re-evaluate it after the implementation of that mitigation strategy to see how the impact and likelihood has been reduced or managed, and then make a decision about how that should be managed thereon afterwards. Now, the key risks, and Peter actually identified some of these, and these are the ones for my 10 pence worth. Design risk, construction risk, operational risk, commercial risk, and regulatory risk. And the key one for me in terms of developing new projects is demand risk. And that is customers predicted to connect and consume in the predicted volume. Now, in terms of actually managing that risk, is that if you can influence or control the organizations or the buildings that are going to connect to that heat network, then you reduce that demand risk, because you know what they're going to consume, you know they're going to connect, and so therefore you actually have a business going further. And Peter has been able to do that through influencing the planning policy in London, but we did not have the advantage of that in Aberdeen, because this was all done back in 1999 through to 2000. So here's a kind of picture of Aberdeen, a city in the northeast of Scotland. It did not have a great experience of district heating. It's not fair to say it didn't have any district heating, because the university campus, all the major buildings on it are linked via a district heating network. Somewhat aged one, but that still exists. But there was no understanding of it within the city council, and our kind of level of sophistication in terms of heat mapping in those days was fairly crude, but generally speaking is that the blue areas that you can see on the map there were identified as areas where there were potential. So we started out with Stockett Hill, which is the area that you can see there, and this was a cluster of 4 high-rise blocks. Now, the key thing is that Aberdeen had 59 high-rise blocks pepper-potted throughout the city, most of them organised in clusters. These were heated by night storage heaters, very unpopular with the residents, high incidence of fuel poverty, and so there was an objective by the City Council to address these. An options appraisal was done, and district heating was found with a CHP was found to be the most appropriate solution in terms of delivering affordable heat to the residents there. Now, these actually kind of gave us the anchor loads, if you like, for the development of a network, because the City Council could commit to actually connecting these to the network. This is the plant room that we put in place to serve these 4 blocks in Stockett Hill, and the planners insisted that it was in the vernacular style of the northeast of Scotland, which is somewhat at odds with the brutalist architecture of the tower blocks behind it. From that is that we moved down to Hazel Head, where there was a school with a swimming pool and an adjacent housing estate, and that was then built out. We then kind of moved on to the multi-storey blocks at Seaton, facing onto the seafront, and you can see that we actually made progress in terms of the architectural style of the plant room, which is shown down on the lower right-hand side. Actually kind of won architectural awards for that, grass-covered roof, curved, and the plant room is actually in the left-hand side. The 2 kind of bits on the right-hand side are the changing rooms for the local sports centre. So moving on from that is that we were able to extend that with a sort of a slight node out at Seaton to connect in an Olympic-size swimming pool, the Aberdeen Sports Centre, which was a joint venture between the City Council and Aberdeen University, but once again a very, very good anchor load. That kind of then moved on to extend that network down to a leisure centre, a municipal ballroom, an ice rink on the beachfront there, and then into the city centre, taking in a health centre, a facility for recovering alcoholics and drug addicts, a halfway house to get them back into the community, to get us into the city centre there. From there is that we were able to, in 2014, connect up various buildings in that area, but also in Torry, which is off the map and to the south of the River Dee. Then going back to Stockett Hill, 2015 to 2016, we're able to extend that to the adjacent housing estate in Ken Cry, and at the top of the picture at Tillydrone, a kind of new network serving all the social housing high-rise blocks in that area. Then opportunistically is that the City Council was doing a road alignment in the northwest of the city, and which necessitated knocking down a lot of social housing, and so we were able to put in a spur out that to serve the new social housing that was being built in that area. Then there's a program in Scotland, the Scottish Energy Efficiency Program, which actually has an element covering district heating, and so we will be able to use access to that to connect up various buildings in the city centre. These are public buildings, the courts of justice, the town hall, the townhouse as it's called, and various others, to kind of densify the network, if you like, in that area. We've now kind of like identified ones which have a potential for the next 2 to 5 years, and the idea is that these will eventually kind of link into a long-term heat main around the city, and that's how we will actually arrive at a ring main around the city that will have multiple energy sources, multiple plant rooms located embedded within that. The City Council is now proposing to build an energy from waste plant north of the river, and that they will have the opportunity of connecting into the ring main to take the heat offtake from that energy from waste plant, very much in the way that Peter was describing earlier. That's where I get to, so thank you very much for your attention, and very happy to answer any questions.
Wonderful. Thank you very much, Michael. Donna, do you have any questions straight away for Michael?
Yeah, just a couple of quick questions if Michael has any answers. He talked about the risk earlier, the internal rate of return that's typically expected by the private sector. What would be his experience being the typical IRRs expected in the UK by ESCOs for district heating systems?
Okay, so do you hear me?
Yep.
Okay. The general benchmark is around about 12 to 15%. Now, the ESCO themselves most probably having to borrow the money if they're debt financing it, or even if they're doing it on their own balance sheet, is that they will have to meet the requirements of their investment committee, and those will be around about kind of a 10%, but they then therefore got to make a markup on that, and so their hurdle rate will be between 12 and 15%. That is my experience. I invite Peter to contribute to see whether he would agree with that.
Yeah, so I agree, Mike. Sort of if you bring debt in, debt comes at lower rates of return, but you have to guarantee payback, and therefore the equity part that would be put in by private sector ESCO would be that much higher. So blended and on average, the 10 to 12%, sorry, the 12 to 15% that you mentioned is borne out in my experience. Certain ESCOs are towards the lower end, and it really depends on the type of project you've got and the size and the potential in it, but that sort of range is what I've seen, Mike.
Yeah. I would reference it back to the risk issue, because most probably the Gospel Oak project that Peter referred to was perceived as being very low risk by the relevant ESCO there. I don't know the details of how they kind of structured it financially, but because they had such a very good anchor load with the Royal Free Hospital, that I should imagine that they were able to accept a very, very competitive rate of return on capital.
Yeah, I'm not privy to what the commercial deal was, Mike. We'd have to approach Camden for that.
Okay, thank you, Michael and Peter, for your answers. Donna, did you have another question you wanted to ask?
Yeah, just a quick question on the retrofit of the electric storage to district heating. Would Michael have any idea of the typical paybacks of such retrofits?
Well, generally speaking, is that we don't use payback as as a financial methodology is it's generally kind of done on NPV or IRR, and that is quite relative to the to debt. So the financing for these projects came from a combination of a commercial debt, what the council, their capital budget, if they were refurbishing one of these blocks, they would have had to have spent something on the heating systems, and so consequently those were ring fenced, that budget, and that was then put into the pot alongside the commercial debt that we were able to obtain, together with any grant funding, and so it was a blend of the three that enabled us to finance these deals. Certainly it could not have done on commercial debt alone.
Okay, that's great. Thanks, Michael.
Okay, thank you very much for the questions and the answers. And we have a couple more exciting presentations coming up. So I think we will for now move on to the next one. We have Ola Nordgren. He is a senior consultant at FVB Sweden and managing director at FVB District Energy UK Limited. He has over 30 years of engineering experience in district energy, both heating and cooling involved there, and his experience includes power plants, distribution systems, and customer heat transfer stations. He has extensive experience with low and medium temperature systems with pre-insulated steel pipes, as well as low temperature systems with plastic pipes. Mr. Nordgren has also been engaged by the Swedish District Heating Association to find solutions for reducing capital costs when building district heating systems. He is a Bachelor of Science in Marine Engineering from the Royal Institute of Technology in Stockholm. So I'll pass the floor over to you, Ola.
Thank you very much, Sarah. This presentation was from the beginning meant to be held by my colleague Stefan Jonsson, as he was one of the guys that were involved in the project in Gävle Hospital here. But unfortunately he's sick in bed and can't attend this meeting. But well, from the beginning we got a very specific question, and we were asked to talk about improvements that we have done in hospitals, and mainly then regarding heating and domestic hot water systems. So so this let's see. So this presentation is a brief explanation how we work to improve the efficiency in the secondary side of the hospital then, and how we modify the heating and the hot water system there. And of course the question we asked ourselves, and it might be the same question as you are asking yourself, is if it is possible to improve the temperature levels in a system inside a hospital, and to improve and also to improve the temperatures out to the district heating network then. So a little bit background. Of course there are two parties here in this project, and one of them are of course the hospital themselves, and the other party is the ESCO, that is Gävle Energi, and they are the one who delivers the district heating to the hospital then. And the ESCO, they could see that they have very bad temperatures back from the hospital, and they also had a need of a high flow there. So of course they could compare with other clients or customers they do have, and as they do have a delta T of around 45-50 degrees back from the other clients, and from the hospital it was only 15-20, they thought that they have to do something about it, and they started discussions with the hospital. And it wasn't that strange that they didn't get that good temperatures back, as the hospitals themselves have very, very low delta T in their system. It was only 2 to 5 degrees. And they also had problems with an increase in Legionella. So, well, both parties find it very useful to do something about the installation in the hospital then. Well, you can read there that the size of the hospital is about 7 megawatt of heat demand, and they have an energy consumption of 16 gigawatt hours a year then. The problems with systems like we have in the hospital there is that they are very large internal secondary heating and domestic hot water systems. And it's very difficult to control the whole system. Like for instance here in Gävle, the hospital only had, I think it was 2 district heating connections for the whole hospital. So that was what we had to deal with from the beginning then. So in 2005 we could start the design and the reconstruction of the system in the hospital then. And the first thing that we did was to look how we should split the hospital in smaller systems. So we choose to divide the buildings into 12 separate district heating stations, and each of them then with its own heat interface unit, AHU then. And to do that, to be able to have all these separate AHUs, we have to install new district heating pipes to reach each building then. So, and here we have the possibility to do it in culverts that they had inside the hospital then. So it was a way to do the connections there. As I said, it was a 2-pipe system inside the hospital, and they have a lot of water heaters or storage for the domestic hot water, and we removed and we replaced all of those storages with plate heat exchanger instead. So we had a direct production of domestic hot water through the plate heat exchangers then. And for the radiator systems, they also had a lot of shunt groups, pump and shunt groups, as they. But we could see that there was no need for them because they were running the same temperature in the whole hospital, so there was actually no need for that. And when we divided into separate substations, 12 separate substations, we could take have the control of the temperature levels from each of these heat exchanger units then. So also the radiator system, as we always do today, we use brazed plate heat exchangers, as they have a very high efficiency. We can take very good care of the temperature and the temperature programs between the primarily and secondarily system. We always use variable speed pumps. We could see we didn't do anything actually about the radiators up on each level of the hospital. Instead, we installed new balancing valves down in the basements. So that was what we did there. But one of the most important things that we have done, and that's generally what one have to look very careful about when you're installing district heating is the control valves on the heat exchanger units. It's very common that you have something you call a KV value of the control valves, and if that value is too big in relation of what they actually should work with, you will have very high variations or in the flow in the system, and that is what you want to avoid. So it's very important that you have the right KV value and as low KV value as possible. And then all the units, energy meters and everything was connected to a superior system, so we can review or monitoring all the system and see directly if there was some temperatures that were seems to be wrong or something like that, so we could do something about it. But it's it's quite simple. These are things that you normally do, but once again, it is a KV value of the valves that are a very, very important thing to look at. So what did we obtain with these measures that we have done then? So for the hospital, they reduced their energy consumption with about 20%. And as we took away all of the storage for the domestic hot water and instead installed the plate heat exchanger, we reduced the risk there for Legionella growth. And then by doing these measures, it's also much easier for the personnel that's running the system at the hospital to analyze the system, to maintain it, and to make individual operation settings and things like that. So they are very satisfied with the system today. And the most important thing is that we have got a much higher delta T in their system today, and that also lower, of course, their energy demand for pumps and those things. And the payoff for the hospital was around 4 years. If we go to the ESCO, the advantages for the Gävle Energi then. Of course, they got also a much better and higher delta T. Today they have an average from the hospital of 45 degrees. And of course, that also gives you lower demand for the pumps, etc. And they have, well, of course, some lower heat losses, of course, also. But another very interesting thing here is again when we have because when we are installing these things that we have done, and we have control valves with the right size that is in the right size, or they have a very low KV value for the system, it gives you a much more stable pressure in the whole network. We shall think of that the ESCO, Gävle Energi, they haven't done this only for this hospital, they have done it for all the big customers that they have. So they have been very active to try to reduce these variations of flow that can occur if you have the wrong valves installed in the system. So Donna showed you a graph in the beginning there about the peak demand for I don't know if maybe it was for the hospital, but we could see that with the right design and the right installation, these peak demands becomes much lower than they are from the beginning, and that also results in the end that the ESCO, the Gävle Energi, don't have to go in with peak production from time to time because we have a more stable network. So that's one of the good things with these installations as well. Stefan Jonsson, that should have held this presentation, he have more knowledge about all the figures, but I think that the cost for this installation was around £1 million or something like that, and where they shared the investment here between the ESCO and the hospital then. This hospital wasn't the first building that they did this. They have, as I said, they have the road to success. Came through a lot of studies that have been done before, and the interesting thing here is that the ESCO, the Gävle Energi, was willing to test all the equipment as well and see how can we improve the system. So from the very beginning, they started with doing tests for apartments, and by what do you say, try and error. They when we design a system, you have certain parameters you have to follow, and we could see that you could go so much lower in these parameters than we thought from the beginning. So as I said there, it was an amazing result. We could change the COVID value from 10 to 1 in some places. So it was very interesting there. And when we had done the tests for the apartments, we went further and took hotels, sport arenas and things like that, places where you almost all the time have some kind of storage for domestic hot water because you think it's needed to have it. But instead we replaced all this. We installed plate heat exchanger and produced domestic hot water in that way instead. And everything that we did was with the same good result. We got a higher delta T from each customer that were connected then. We have, before this presentation, we have discussed with both the hospital and Gävle Energi if you would like to come and show them, and they are very. If you would like to come and see it, it's for interest for them as well then. So yeah, so that's all for me by now. Thank you.
Okay, thank you very much, Ola, for sharing the experiences from Gävle and Gävle Hospital. Donna, do you have any questions straight away for Ola?
No, I suppose just a comment. It's all very relative information there for us in particular. Is very interesting to see how they reduce or how they increase the delta T and the kind of short paybacks. I suppose just one thing I just want to be clear: the actual investment in the hospital for the refurbishment and the kind of the new system. This investment was shared between the ESCO and the hospital, and the ESCO being the district heating supplier. Is this correct?
Yeah, they shared the investment between each other. So it was it can be done in very many different ways, but in the city of Gävle, the ESCO owns their substations. They owns the AHUs in the buildings. So of course that makes it a little bit easier for them as well to do changes in the unit there. But here it's more about telling you the principles of how it can be done. But they shared the investment about 50-50 almost.
That's great. Thank you.
Okay,
Hello.
thank you very much.
Hello.
And we also
Hello. Do you hear me?
okay, and
Yeah.
we also have a question from one of our participants. So we have from Yuris Goluvnovs. Sorry if I pronounced that wrong. We have the question: what are the requirements for energy supply security of hospitals regarding backup heat source time of use per annum and the main source time of use in order to approve permanent ability to work?
So it is. Many times the hospital have their own boilers in case of some kind of emergency. But many of the hospitals they don't use the boilers. They have taken them away, and instead they have a contract signed with the ESCO that the ESCO have mobile boilers that if there should be an interruption for a longer time, they can transport this boiler to the hospital and put it outside, and then they have prefabricated connection that they easily can connect the hospital to this transportable boiler then.
Okay, thank you very much, Ola, for that answer. And we've got a thank you from Yuris as well. Wonderful. Then we will move right along to our final speaker for today. We have Per-Anders Tauson. Per-Anders is the head of power and heat at Sweco Sweden, where he's also responsible for the development of district heating and cooling with a focus on the United Kingdom, Belgium and the Netherlands. He has many years international experience in the energy sector, including working on the development of district heating networks in a variety of locations. So I will pass the floor over to you, Per-Anders.
Yes, thank you very much. I will.
Konstigt. Per-Anders, your sound disappeared. Are you using a headset?
I don't hear anything.
I will try to reconnect my. Sorry for this, because this equipment has been used for several years and it usually works very well. So I will just try to. We have a quite brief presentation, and I also, as we read the material from Dublin, we also thought that it could be very interesting to discuss what we have done in what we're doing in another project in UK right now. So I also invited the project manager for that project, Michael Jönsson. So he will be part of this presentation in a little while. So just for you who don't know Sweco very well, we are 14,500 employees, and we are 800 in the UK, and very heavily based in Sweden and the rest of western part of Europe. I will take this picture as we discuss the CHP. how to supply the district heating nets. We have been working quite much with this for over several years, and one project is, and I don't know if you know it, but it's a Filbornaverket in Helsingborg. It's Öresundskraft who owns this, and this is a 80 megawatt waste to energy power plant with a steam with a heat accumulator of 45,000 cubic meters, which supplies can cover the district heating demand for several days. This is very used over high demand times, of course. This was put in operation 2013. It works very well, and what we then have been working with is to connect the district heating net between the city of Helsingborg, Landskrona, and the city of Lund. And this is also to make to have a redundancy in the net, but also to optimize the investments to decrease the asset portfolio and the value of the total investments in the grid. So this works very well now, and we've been optimizing this net with all these three energy companies working in owns the net, and we are optimizing then how to produce the cheapest energy, of course, and this has make them more competitive towards heat pumps and other competitor solutions. Then I would like to also mention this project we have done here in Malmö, which is also a quite complicated network with several inputs from both industry and both other suppliers. And I think that backup system now is running extremely well. It's very, very high availability on the net with a very nice, it's very good optimized, that net. So I think this is just an example of how you can improve your redundancy in the net with a quite low cost and optimized cost. Then I would like to mention, go further to the wrong button. We've been working quite much in Stoke-on-Trent together with the Nordic Heat, and Nordic Heat supplies advisory on business models and tariffs and so on. But what we do then is that we we do this assignment in different phases here, and I think it's quite similar to the situation you are in Dublin, what they've been facing in Stoke-on-Trent. So Michael, I will turn the computer on here so we can. Sorry. Michael, who is the project manager for this, together with the Stoke-on-Trent team and Nordic Heat, who will give a little explanation of how we have thought from the beginning in this project and what challenges we have overcome the last. Yeah, we've been working with it for 1 year now. So please, Michael.
So we started this feasibility study early last year in 2016, and Stoke had at that time already done some preparatory works by having done a survey of potential customers to a planned district heating system. And The feasibility study we prepared had as the main focus of finding the costs, of course, and to try to optimize and keep the costs as low as possible for the investment in the system. So the plan, you can see the network on the slide, and the total number of connections is expected to be about 119 with a 24 megawatt of connected load after the 3 years of build-up time that we expect. The plan is that in the long term, the supply to the system should come from either geothermal energy or from an energy from waste facility that is already existing, but today producing only electric power, and the heat is not utilized at all, or a combination of geothermal and energy from waste. What we did was to plan a system initially based on 3 islands, which should be supplied by biomass pellets from mobile plants initially. And then after year 3 or 4 to interconnect the 3 islands into a system which could then be supplied by the new baseload facilities. And when it comes to the customer side, the anchor loads are in the area marked Y1, which stands for year 1. And the buildings in there are more or less already secured, so to say, for the system, as they are university and college buildings and some municipal buildings as well. So this feasibility study was finalized before the summer last year, and then discussions has been going on, and late autumn last year the City Council in Stoke formed a new dedicated vehicle for the district energy called the Potteries Energy Limited. At least that's the preliminary name of it. So what we have just started now this year is the implementation phase of the project. So we are right now working with some pre-design phase or some conceptual design of the system. And before the summer, we should have finalized input for procurement, technical input for procurement of the first generation plants and the network and the customer connections. And then the idea is to start the procurements after the summer and to have the first part of the system in operation before the heating season starting in 2018.
Yeah, this is just a brief explanation and a description of what we have done so far in the Stoke project. It's not any hospital connected in it, but it's a lot of municipal buildings and the university. Yeah. So I think that is what we wanted to just tell in this presentation. So thank you.
Okay, thank you to both of you. Then I think seeing as time is running away from us, we will move straight on to our Q&A. So of course, first I would like to ask Donna if she has any further questions for any of our presenters. And for those of you in the audience, if you have any questions you would like to ask, just a reminder that you can enter those into the chat function, which you can use by accessing the little speech bubble at the bottom left of your screen. So feel free to write those in. and we can read them out. But first of all, over to Donna. Do you have any questions you would like to ask our panelists?
We've no specific questions at the moment. Just to say, I suppose, thanks to all the speakers for their contribution, and I suppose a lot of it we can take away now and input it into our South Dublin project. I think particularly the presentation on the hospital from Ola was very interesting. We might take him up on that offer of a visit to Javle Hospital at some stage. But yeah, I have no further questions at the moment.
Yes, you are very much welcome to come and visit Javle Energy as well then.
All right, then we've had a very interesting and varied series of presentations on this topic, so I'd really like to thank everybody for participating. I'd particularly like to thank Dublin for discussing their challenges with us, and I'd like to thank our presenters for helping us to discuss some of the things that Dublin might want to think about for starting a heat network in general and for connecting a hospital in specific. So that's all from us today.